Unit 12, Structural Metals. Metal is available in a large range of shapes and sizes. Figure 12-1 shows the customary methods for designating or building structural shapes on prints. While these shapes are generally accepted, there may be differences in the way they are used by some companies. Stock structural shapes that have been cut, machined, bent, rolled, spun, stamped, or drawn and combined with castings, forges, and extrusions can be found in all products fabricated by welding. Stock shapes are used whenever possible to keep material and machining costs at a minimum. What is metal? Metal plays an important role in welding. How would you define the term metal? Metal might be described as a tough, malleable material with high tensile strength and the ability to withstand high temperatures without melting or burning. This definition would be only partly correct. Only some metals have these characteristics. There are metals that do not have these features. For example, mercury is a fluid at normal room temperature. Body heat will melt gallium in the palm of your hand, and lithium is so soft your fingernail can scratch it. Can you tell by looking at each piece of metal whether it's ferrous metal or non-ferrous? Excuse me. A ferrous metal contains iron, while a non-ferrous metal contains no iron. Could it be an alloy? An alloy is a mixture of two or more metals. Perhaps it's a pure metal, such as copper, tin, zinc, etc. A pure metal is a pure metallic element. When a pure metal is used as a principal alloying agent in an alloy, it is known as a base metal. There are no simple answers to these questions. Additionally, study and experience, however, can help a welder develop a working knowledge of metals to make a job safer, easier, and more successful. Metals supplied for welding. The welder usually has little or no control over the metal furnished for welding. It must be assumed metal provided by the employer for a specific job meets print specifications. The metal supplier or the mill that produced the metal can certify the metallurgic characteristics of the metal. As a welder, it is important to know the characteristics of the metals you will be welding. This is important for three reasons. It aids in ensuring the welds meet design specification. It permits you to take special safety precautions when welding metals that give off toxic fumes and residue. It allows you to match the filler material to the base metal. Metal specifications. Metal specifications or specs are usually located in a special section of the title block. Figure 12-3 shows an example. There are times when the metal specs may be given elsewhere on the drawing. You can think about metals in a variety of ways. For example, you can think about a metal's shape, finish, atomic structure, alloy elements, and strength. For those who work with metals extensively, a more specific method of specifying metals may be needed. Professional organizations, the military, steel mills, testing laboratories, and companies may have a detailed method of specifying metals. A few common organizations that have developed metal specifications include the following: military, American Iron and Steel Institute, Society of Automotive Engineers, American Society of Mechanical Engineers, ASTM International, some larger manufacturers such as General Motors or Caterpillar. The American Iron and Steel Institute and the Society of Automotive Engineers uses a method of specifying steel by the steel chemistry. The AISI SAE systems use a 4-digit code. The first two digits indicate the type of steel, and the next digits indicate the approximate carbon content expressed as a percentage. An example is 1018. The 10 indicates plain carbon steel. It contains no special alloying elements. The 18 indicates 18.18% carbon content by weight. Notice the dimensional point is in front of the 18. That is a very small amount of carbon to give the steel strength. Steels with carbon content of 1% to about 1.5% are tool steels, and these steels are seldom welded. A complete list of AISI or SAE steel can be found online or in a metallurgy handbook. Some SAE steel classifications include a letter between the numbers. The letter L indicates the addition of lead to improve machining. The letter B indicates the addition of boron to improve hardenability. ASTM International was formed over a century ago and until recently was called the American Society for Testing and Materials. ASTM was formed to develop railroad standards. The standard development for railroad industry led ASTM to be one of the largest voluntary standards organizations in the world. ASTM International standards cover a wide variety of materials, products, and testing methods. The ASTM International specification for steel start with the letter A followed by a number. Excuse me. An example is A36. A36 is a low-carbon structural steel and is one of the most commonly welded steels. A36 is supplied as plate, angle, channel, and beam shape. Another example of ASTM International Steel specification is A53. A53 is a low-carbon steel that has been rolled into a pipe shape and seam welded. Chemistry and strength data must be found by researching the specification number. Unlike the AISI SAE specification, no chemistry data is found in the number. The Unified Numbering System, or UNS, was established by the ASTM and SAE. The UNS system uses a letter and a 5-digit code. The first 4 digits usually are the same as those used in the AISI SAE system, and the last digit indicates an additional element. G is used to designate all steel except tool steel. An example is G10180. Notice that the first four digits are the same as those used for AISI SAE system. This makes it easier to use to understand both systems. To secure the complete metallurgic specifications of the metal, including the chemical and mechanical properties, it is necessary to refer to the appropriate metals handbook or online source. If you look up specifications online, always check the accuracy of the data by reviewing the last 2 websites.